loading conditions are applied to individual panels. In an effort to ensure the designer can easily navigate through the panels, the split-screen view shows the cross-section of the panel being selected and an elevation view indicating where the subject panel is in the wall. On the left of the graphics, the user can input the loading information. The slope behind the wall is input in degrees. For broken back slope conditions, a crest offset is input. Below this, the user can input live and dead loads as well as their respective offsets. Keep in mind that if you have a crest offset, the live and dead load offsets must be at least equal to the crest offset or 0. The loads are shown graphically in both the section and elevation views. This is to remind the designer which panels have been looked at. If you are lucky and the loading conditions are the same along the length of the wall, we can now just hit the Extend Left and Extend Right buttons to copy these conditions to all panels. We can see that the elevation view graphic shows that loading has been applied throughout the wall. If this is not the case, move the panel on the left or right where the conditions change and modify them. Then extend to the remaining of the wall. Now that we have defined our loading conditions, we can move on to actually designing the wall. The Design tab has been arranged to give the designer immediate feedback on all potential modes of failure on the fly. Similar to the loading screen, the elevation and section views allow for easy navigation on your position in the wall. To the right of the section graphic, Vespa provides a quick results screen, giving instant feedback on the minimum factors of safety for the various modes of failure. This screen also allows you to toggle between static and seismic analysis. Below this, the results of the Internal Compound Stability Analysis, or ICS, is provided, both for static and seismic conditions. The main purpose of this screen is to include Geogrid reinforcement in the wall, if applicable, and to check the stability of the design. For reinforced walls, the first step would be to select the Geogrid reinforcement you want to use. The drop-down menu includes all of the geogrids you selected in the Reinforcement tab to be used in the design. There are now two ways you can approach the design, manually or automatic. The Generate command creates a trial design that attempts to meet all the minimum factors of safety and empirical checks. Prior to hitting the Generate function, it is recommended to decide whether you want your wall to have uniform geogrid lengths throughout, or if you're going to allow variable lengths. If you wish to have uniform grid lengths, select this toggle. If the generated design is not acceptable to the designer, it can be modified. Geogrids can be added or removed by selecting the layer in the graphic, or by using the Course drop-down menu, then hitting either the Add or Remove buttons. If the Vespa Generate function came up with a geogrid length, as shown, but the designer wishes all layers to be longer, the new proposed grid length can be entered into the Reinforcement Length field, and the Edit All button is selected to modify all grids to one specified length. An example of this would be if a certain geogrid length is required for some other reason, such as global stability. If the designer wishes to move all geogrids either up or down, simply select the Move Up or Down buttons. Once the designer is satisfied with either the Generate design or the Modified design, the design is analyzed using the Analyze Panel button. In the Quick Results screen, the minimum factors of safety for all modes of failure and empirical checks are shown for both static and seismic conditions. The quick results are there to provide the designer with immediate feedback on the design to ensure they are on the right track. For more in-depth review of results, the full output function will provide this, which we will demonstrate shortly. Note that a green check mark is shown for all analysis that pass, while a red X is given for those that do not. This allows the designer to quickly pinpoint areas of the design that require attention. The designer has the option of selecting Include ICS when analyzing the panel. While the designer is fine-tuning the geogrid design, it is recommended to not include ICS when just checking the design, as this will slow down the calculation slightly. When the designer is satisfied with the results of the internal and external analysis, it is recommended the ICS calculation be performed. We will now run the ICS calculation since all of our other checks have been confirmed okay. The ICS results shown in the bottom right quadrant provide the lowest factors of safety of the thousands of iterations performed in the ICS analysis. For each radius point shown in column 1, the entry point is indicated, which is the location along the surface of the ground profile at the top of the wall. At the other end of the trial slip surface, the course through which it terminates is also provided. By providing this, the designer can again pinpoint areas of the design that need attention. The section graphic also clearly indicates those trial circular failure planes that do not meet the minimum 1.3 factor of safety, and visually the designer can decide what measures would have to be taken to improve the situation. By using the Edit All function, we will increase the grid length by a nominal amount until our analysis passes. Another approach would be to add another layer of Geogrid below this one. So now our panel design is complete. Unfortunately, we have quite a few more panels that have not been designed yet. Not to worry. In the next tutorial, tutorial number 6, we will show you how to easily deal with continuing to design the rest of the wall quickly and efficiently.